features of Intel 8085 microprocessor. 1. 8085 microprocessor is an 8-bit microprocessor. It can able to process 8-bit data simultaneously. 2. It is 40-pin DIP. It is manufactured within MOS technology means. N-type metal oxide semiconductor logic uses N-type field effect transistors. MOSFETs, to implement logic gates and other digital circuits. 3. 8085 microprocessor provides on-chip clock generator. There is no need of external clock generator, but it requires external tuned circuit like LC, RC or crystal. 4. The maximum clock frequency of 8085 microprocessor is 3 MHz. Whereas minimum clock frequency is 500 kHz. 5. 8085 provides 74 instructions with the following addressing modes. 1. Register addressing mode. 2. Direct addressing mode. 3. Immediate addressing mode. 4. Indirect addressing mode. 5. Implicit addressing mode. Pin 1 and 2. X1 and X2 input pin. 1. Connected to a crystal, LC or RC network. Crystal or RC network connections to set the internal clock generator. 2. X1 can be used for external clock input from a logic gate. 3. The input frequency is divided by 2 to give the internal operating frequency. Suppose we have give about 50 Hz frequency to the input pin of X1 and X2. Then 50 Hz is divided by 2 and gives 25 Hz to the internal operating frequency. Pin 3. Reset output pin. 1. Reset indicate microprocessor is being reset. It means by using this pin we can able to know whether the microprocessor is reset or not. Reset equals 1. Microprocessor is reset. Reset equals 0, microprocessor is not set. 2. The signal is synchronized to the processor clock and lasts an integral number of clock periods. It starts and ends with the clock of the processor. Pin 4. SOD, serial output data. 1. It is a 1-bit output port. 2. 1-bit data can be externally written in this port. 3. To write data into this port, some instruction is used. 4. The data that is to be written in this port must be stored in the A7th bit of the accumulator. 5. Bit A6 of the accumulator is known as SO, serial output enable. This bit must be set to 1 to enable serial data output. Pin 5. SID, serial input data. 1. It is an 1-bit input line. 2. 1-bit data can be externally read and stored using this SID line. 3. The data that is read is stored in the A7th bit of the accumulator. 4. RAM instruction is used to read the SID line. Pin 6. Trap, input pin. 1. Trap interrupt is a non-maskable restart interrupt. 2. It has the highest priority. Pin 7 to 9. RST 7.5. RST 6.5. RST 5.5. Input pin. 1. It causes an internal restart to be automatically inserted. 2. They have higher priority than INDR. 3. It is maskable interrupt, pin 10. INTR, input pin. 1. General purpose interrupt. Sampled only during the next to last clock cycle of an instruction and during hold and halt states. 2. It is maskable interrupt. 3. If it is active then PC, program counter, will increment and an INTA will be issued. Pin 11. INTA, interrupt acknowledge, output pin. 1. It is used instead of RD, read, during the instruction cycle after an INTR, interrupt request, is accepted. 2. It can be used to activate chip or some other interrupt port. Pin 12 to 19. AD0 to AD7 input or output pin. 1. Transfer or receive data from I/O device to microprocessor or vice versa. 2. Put lower memory address on the bus during the first clock cycle of a machine. Cycle. Pin 20, VSS. This pin of the microprocessor is connected to the ground. Pin 40, VCC. This pin of the microprocessor is connected to the positive terminal of 5V DC power supply. Pin 21 to 28. A8 to A15. 1. The most significant 8 bits of the memory address or the 8 bits of the I/O address. 2. 3 stated during hold and halt modes and during reset. Pin 29, S0, 33, S1, and 34 I/O/M. S0, S1 and I/O, M, machine cycle status. These 3 are output pins of the microprocessor. With the combination of these pin, microprocessor performed different types of work like read or write on the memory or output device. If I/O, M is 0, S1 is 0 and S0 is 1, then microprocessor status is memory write. If I/O, M is 0, S1 is 1 and S0 is 0, then microprocessor status is memory read. If I/O, M is 1, S1 is 0 and S0 is 1, then microprocessor status is I/O write. If I/O, M is 1, S1 is 1 and S0 is 0, then microprocessor status is I/O read. If I/O, M is 0, S1 is 1 and S0 is 1, then microprocessor status is opcode fetch. If I/O, M is 1, S1 is 1 and S0 is 1, then microprocessor status is opcode fetch. If I/O, M is 1, S1 is 1 and S0 is 1, then microprocessor status is interrupt acknowledge. This symbol indicate 3 state, high impedance. Unspecified. S1 equals used as an advanced RW status. Pin 30. AL, address latch enable, output pin. 1. It operate during first clock state of a machine cycle. 2. Enables the address to get latched into the on-chip latch of peripherals. Pin 31. WR, write control, output pin. 1. It is an active low pin. 2. 3 stated during hold and halt modes and during reset. Pin 32. Road, read control, output pin. 1. It is an active low pin. 2. 3 stated during hold and halt modes and during reset. Pin 35. Ready input pin. 1. It is high during read and write cycle. It indicates that the memory or peripheral is ready to send or receive data. 2. Read equals 0, it is low. Then, microprocessor will wait an integral number of clock cycles for ready to go high before completing the read or write cycle. Pin 36. Reset an input pin. 1. Set PC, program counter, equals 0. 2. Reset the interrupt enable and HLDA, hold acknowledge, flip-flops. 3. It is an active low signal. Pin 37. CLK, clock, output pin. 1. It is used as a system clock. 2. The period of CLK is twice the X1 and X2 input period. Pin 38. HLDA, hold acknowledge, output pin. 1. Indicates that the microprocessor has received the hold request and that it will relinquish the bus in the next clock cycle. 2. HLDA goes low after the hold request is removed. 3. The microprocessor takes the bus 1/2 clock cycle after HLDA goes low. Pin 39. Hold input pin. 1. Indicates that another master is requesting the use of the address and data buses. Microprocessor receiving the hold request will relinquish the use of the bus as soon as the completion of the current bus transfer. 2. The processor can regain the bus only after the hold is removed. 3. When the hold is acknowledged, The address, data road, WR, and IO, in lines are 3 stated.